Hey, welcome back. This is our last video on generators for now, and we're going to talk about a topic called generator expressions. So these are basically what list comprehensions are to lists, but for generators. The goal is just a nice, simpler, easy syntax to create generators on a single line. Just like with list comprehensions, there's nothing that you can only do with a list comp. It's just a nice way of writing something else that might take a couple of lines. So we can create generators from generator expressions. They look like list comprehensions. And most importantly, at least so far, we use parens instead of list brackets. Suppose I had a really simple generator, like I just call it nums. And all that it does is for num in range, let's go 1 to 10, it's just going to yield num. I'll copy it over to my shell here. And then I could just do g equals nums, like that. And then we call next on g, and so on. And that should all be review. Okay, so there's a shortcut. If we want to do it on a single line, we can just do this. G equals parens, and then we just do num for num in range 1, 10. And if you look at what g is, it's a generator object, which is the same thing as this old version of G. I should have shown that to you first. If I remake it though, and we look at G, it's a generator object, but here it tells us it came from a generator expression. Here it tells us it was defined with the generator function nums. All right, so otherwise they're identical. If I call next on this one, we get the same thing. I really shouldn't have gone with G, so let's change this to, I don't know, G2. These are terrible names. And if I do next on G2, keep going, it's the same thing. All right, and then eventually we hit the end and we get the stop iteration error. Cool. So that is our first generator expression. If we had replaced it with list brackets, if I had done, I don't know, let's just do L equals, and then num for num in range 1, 10. But now we get all the data in one list all at once. So that shouldn't be news either. That's how list comprehension works. But when we use a generator, we get one thing at a time. Well, it gives us the generator object, and then we iterate over it by calling next. Whether we're using a loop or we're calling next manually on our own, we get one item at a time. But we can take advantage of this for things like, I think I showed you when we had sum. If I want to sum all of these numbers together, there's no reason that I necessarily have to put them in a list. So if I copy this, I could do that and I get 45, or I could do this and I also should get 45. But in this case, I'm using a generator expression and passing that in. And in this case, I'm using a list comprehension, which is giving me a big list. It's only, 10 things long, but it's giving me a list. I'm passing that in. So there is a difference. Okay, so let me show you the actual difference on calling sum with a generator expression versus a list comprehension. And with, let's say we're summing like the first million or 10 million numbers together. In order to time things, I'm going to import time. This is not a very precise way of timing, by the way. There are things you can download, modules out there that actually are more precise for benchmarking, but this will give us a good enough guess, an approximation. So I'm going to have a variable called gen start time for generator equals time.time. So that'll be time, basically now, whenever I run the script. And then I'm going to try doing print. Let's do sum, and we're not using a list comprehension, so it's just going to be n for n in range. And what is this here? That's a million. Let's do 10 million, like that. Add on my last parenthesis there, and then let's do a variable down here called gen stop equals time.time, so that's now, minus gen start time. Does that make sense? We're capturing the start time, we're doing the thing, and then afterwards we're taking the current time, subtracting the start time. Okay, then we're going to do the exact same thing, except I'm going to call all of these variables list start time, list stop, and we'll add in list comprehension there. So now we're turning it into a list first and then summing all those things together. Okay. Lastly, let's do a print f string And do we want to put this whole thing in there? Sure. Let's take this took colon, and then we'll do gen stop. Actually, technically stop is not the right word for that. Let's just do gen time and list time. Duplicate this, except this time the list brackets there, took list stop. Okay, so we're running the exact same code, except one we're passing in a list comp, the other one is a generator expression, and then we're timing both of them, and then at the end printing, and I did change this to be gen time and then list time instead of stop. Okay, let's make sure I don't have any errors. Try running it. Fingers crossed. Okay, so it prints both of them out, and then we can see the difference over here. It looks pretty small when we're doing 10 million, but you can see the generator was faster, although I'm not necessarily comfortable with that margin because time is somewhat imprecise. Let's do an extra 0. How about now? Might take a moment. I might fast forward. I can't fill this time. What am I supposed to talk about? Oh boy, crippling fear here. I don't know what to talk about. Well, it's raining here. All right, there we go. That is a big difference. Look at that. 6.75 seconds using a generator expression. 10 seconds using a list comprehension. Massive difference. And of course, the reason for that is that here, when we're using sum, it makes the entire list first, and then it has to go over the entire list and add everything together. So it makes it first and then adds it, and it has, what is this, 10 million, 100 million? Yeah, 10 million digits. That's a very long list. Versus here, we're not creating an entire list. We're just taking one thing at a time and adding it to a sum, and we just go one, add, until we hit the end of the generator, and then we have the total. So very, very different approach and a significant reduction in time, as you can see. All right, so that's generator expressions. If you can use them, they often can save some time.